You're listening to DTFHN for June 28, 2026. I'm your overcaffeinated and under-abstracted host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who could build anything argue about whether they should. Today, everything old is new, everything simple is radical, and everything corporate is optional. Let's get into it. I've spent enough time building automated systems to know that the most tedious part is never the engineering. It's the compliance paperwork, the FCC filings, the ethics guidelines, the emergency protocols that read like they were written by a committee of insomniacs who wanted company. So when I tell you that Marfa Public Radio has weaponized this paperwork, I mean it as the highest compliment. Marfa Public Radio puts you to sleep is exactly what it sounds like. Staff members read aloud the driest, most essential documents that keep their station running. FCC compliance forms, NPR's Code of Journalistic Ethics, internal protocol. And they do it with the explicit hope that you will lose consciousness before they finish. It's a membership drive pitch disguised as a sedative, or maybe the other way around. Either way, it works. And there's something genuinely delightful about the transparency here. Most institutions treat their operational scaffolding like a trade secret. Marfa just hands you the manual and says, "Here, this will bore you to sleep, but also, this is what it actually takes to keep a community radio station alive in the West Texas desert. 24 hours a day, 7 days a week. Except when lightning strikes." Which in Marfa is not a metaphor. They literally go dark during electrical storms. Pull this thread a little further. Public radio is one of the last pieces of genuinely open broadcast infrastructure in the country. Anyone with a receiver picks it up. No login, no algorithm deciding what you hear, no subscription tier. Marfa serves a coverage area where the nearest city is hours away, and the station runs on donations and sheer stubbornness. The fact that they can turn their own bureaucratic burden into content, into a reason to engage. That's the kind of resourcefulness you only get from people who build things because the community needs them, not because the quarterly numbers demand it. The comments are worth noting here. Someone points out boring books for bedtime, has a similar concept but keeps accidentally picking interesting material. That's the beauty of Marfa's approach. FCC compliance documents are guaranteed boring. You cannot accidentally make them compelling. It is perhaps the only genre-proof format in podcasting. When you wake up, they suggest donate. Keep the station running so they can keep reading you the paperwork. It's funny, it's honest, and it's a reminder that the infrastructure we take for granted, the signal that's just there when you turn the dial, runs on people who care enough to read the fine print so you don't have to. Moving on. 1,000 lines of bash. That's it. That's the entire blogging platform. No database, no framework, no package manager, no container, no deploy pipeline. One file. You drop it in a public folder on any server. Type /bb.jashpost, and your text editor opens. When you close it, you have a blog, HTML pages, RSS feed, index, styling, all generated by the same utilities that have shipped with every Unix system for 40 years. Date, grep, sed. Base name. Let's pull this thread because the first principles question here is genuinely interesting. What does a blog actually need? Strip away everything the modern web stack has taught you to assume. A blog needs to turn text into HTML files and put them where a web server can find them. That's the entire requirement. Not a runtime, not a process, sitting in memory, waiting for requests. Not a database storing your posts as rows. Static files in a folder. The web server you already have does the rest. Carlos Finaloza built Bashblog because he wanted exactly that and nothing more. The engineering here is worth appreciating for what it refuses to include. It auto-detects whether it's running on GNU, Linux, BSD, or Mac OS, and adjusts its command flags accordingly. That's the kind of quiet portability work that separates a script someone wrote for themselves from a tool that actually works everywhere. It handles drafts. It generates RSS. It supports Markdown. If you have a converter installed, falls back to HTML if you don't. Zero dependencies means zero dependency hell. There's something clarifying about constraints this tight. When your entire platform fits in a file, you can read in one sitting. There's no abstraction layer hiding decisions from you. The configuration is just shell variables. The deployment is just files in a folder. Every piece of complexity that a modern CMS brings. The admin panels, the plugin systems, the update cycles, the security patches for the admin panels and plugin systems. None of it exists because none of it was needed. One of the comments captures this perfectly. Someone says they use it if it shipped in their OS's standard package repo, and that instinct is right. This is the kind of tool that belongs alongside cron and grep and all the other quiet utilities that just work. 1,000 lines of bash, doing exactly one thing, doing it well, requiring nothing you don't already have. The tools exist. They always did. Sometimes the most powerful thing a developer can do is refuse to add more. Now, if doing more with less is the theme. Pause. Someone just wrote the playbook for building a high-performance compute cluster on consumer AMD hardware. Someone in the comments calls this bridging the gap between 24-gig consumer GPUs and the data center. And they're right, but the word bridging undersells what's actually happening here. 2 framework desktop mainboards, each with an AMD Strix Halo chip and 128 gigs of unified memory connected by a single copper cable. That's it. That's the cluster. 256 gigabytes of inference capacity running, distributed VLLM with tensor parallelism, and the whole thing probably fits on a desk you bought at IKEA. The setup guide is on GitHub. It's a shell script, some container configuration, and a 2E menu. You plug in the cable, run the script, pick your model. The technical achievement hiding underneath that simplicity is RDMA. Remote Direct Memory Access, which lets one node write directly into the other node's memory without bothering the CPU or the operating system. 5 microsecond latency instead of 70. The 2 machines don't feel like a network. They feel like one box. This has a historical parallel that's almost too on the nose. In 1994, the Beowulf project at NASA Goddard took 16 commodity 486 machines, connected them with Ethernet, and showed you didn't need a Cray to do supercomputing. You needed a stack of cheap PCs and the right software. Thomas Sterling and Donald Becker essentially democratized high-performance computing with hardware you could buy at a store. 32 years later, someone's doing it again. Except now, the workload is AI inference, and the commodity hardware is a pair of laptop chips in desktop enclosures, connected with a 100-gig DAC cable and an open-source RCCL patch. The comment section is where this gets real. Anti-res. Yes, the Redis creator. Oh, shows up by proxy. Someone mentions his DS4 project doing 4-bit quantized inference across 2 Strix Halo machines. Another commenter is building a 3-node agentic OS factory designed to be maintained by local agents running on the cluster itself. These aren't hypotheticals. These are people shipping working systems on hardware that costs less than a single enterprise GPU. The comedy of unintended consequences here is that NVIDIA spent years building an ecosystem so locked down that running 2 GPUs across machines required proprietary NVLink, proprietary NCCL, proprietary drivers. AMD's answer was to publish a setup guide on GitHub with a shell script that auto-detects your RDMA devices. The refresh toolbox script literally sniffs for InfiniBand hardware and configures the container accordingly. You don't need to understand RoCv2 protocol negotiation. You need to run a bash file. A 100 gig direct attached copper cable costs about $40. The machines cost more. Sure, but the knowledge is free. The software is free. The guide is free. And when 2 people in the comments are already extending this work in directions the original author didn't anticipate. That's not a setup guide, that's a bootstrap. Open source infrastructure is one thing, but sometimes the bootstrap is pure joy, like bringing classic games back to life. In 1995, Westwood Studios shipped Command & Conquer and changed real-time strategy forever. Within a decade, EA bought Westwood, shut it down, and left those games to rot on operating systems that no longer exist. The originals won't even launch on a modern machine without a fight. That's what happens when a corporation owns culture. It decays on their cycle. OpenRA refused that timeline. A community of developers spent nearly 2 decades rebuilding those games from scratch. Not porting them, not emulating them, re-implementing the entire engine in C#, cross-platform, with modern networking, proper widescreen support, and gameplay balance refined by thousands of hours of competitive play. Tiberian Dawn, Red Alert, Dune 2000. All playable right now. On Linux, Mac, Windows, for free. Follow the logic of proprietary game preservation to its conclusion. If the only legal way to play a classic game is through the rights holder, and the rights holder has no financial incentive to maintain it, then the game simply ceases to exist. That's not a hypothetical. That is the default outcome for almost every game ever made. The proprietary model doesn't just fail to preserve games. It structurally guarantees their extinction. The only games that survive long-term are the ones communities are allowed to touch. What makes OpenRA remarkable is how thoroughly it proves this. The competitive scene is alive. People in the comments are watching tournament replays, debating balance changes between Allied artillery and Soviet Tesla coil. Arguments that are only possible because the code is open and the community can iterate. One commenter points out that EA eventually open-sourced parts of the original Command & Conquer code. Credit where it's due, but OpenRA didn't wait for permission. They built it anyway, and the result is arguably better than what EA shipped 30 years ago. This pattern keeps repeating. Augustus rebuilding Caesar III. Julius forking into Augustus when the goals diverged. Communities taking abandoned commercial software and not just preserving it, but improving it, because open code lets 1,000 people contribute what one company couldn't justify funding. The original Westwood developers built something worth saving. OpenRA is proof that when you let people touch the tools, they will save it, whether the corporation helps or not. Moving on. How many decisions does your software make about your software before your software does anything useful? Every time you send a prompt to a large language model, something has to decide which model gets it. And in most architectures today, that something is another model. A train classifier, an LLM judge, a hosted API endpoint. You're burning tokens to decide where to burn tokens. There's a word for systems that consume their own resources to function. And it's not efficient. Wayfinder Router asks a question that sounds almost naive. What if you just looked at the prompt? Not semantically, structurally. How long is it? Does it contain code blocks? Are there headings, lists, mathematical notation, hard constraints? These are features you can extract in microseconds, deterministically with zero network calls. The routing decision becomes a score, not a prediction. Same input, same output, every time. The architecture here matters more than the accuracy numbers, and the project is refreshingly honest about both. Point it at router bench and it performs no better than random on short prompts that happen to be hard. An innocent-looking what is the 100th prime has no structural tell. The maintainers document this. They ship the benchmark. They tell you exactly where the tool loses. That kind of transparency is engineering confidence, not marketing confidence. What holds up is the part worth relying on. Deterministic. Sub-light setting. Offline. Your cheap prompts. Summarize this. Fix my typo. Reformat this paragraph. Stay on your local model. The hard ones go to the cloud. You stop paying frontier prices for commodity work. One commenter raises the context problem. If prompt A routes local and prompt B routes cloud, how do you maintain conversation state across models? It's a real limitation, and it's worth naming. Wayfinder answers, which tier, not which session. That's a composability question the ecosystem hasn't solved cleanly yet. But look at what's actually running here. The routing layer is open source. It runs on your machine. It calibrates on your data. It composes with whatever gateway you already use. Leader Open Router, anything OpenRA compatible. The decision about where your prompts go happens on hardware you control. Using logic you can read and modify. Every routing layer is a control point. The question is always whether that control point answers to you or to someone else's pricing API. Wayfinder keeps the decision local, keeps it legible, and keeps it free. The rest is up to you. We talked earlier about learning by building 7. Here's a community taking that to its logical extreme. Matching. That's the word that unlocks everything about this project. In decompilation, matching means you write C code that compiles down to the exact same sequence of machine instructions as the original binary. Every register allocation, every branch offset, every single bit identical, not approximately right, not functionally equivalent. Byte for byte perfect. Decomp Academy teaches you how to do this for GameCube games. Star Fox Adventures, Pikmin, Metroid Prime, Mario Party. And it does it through a web interface where you can practice right in the browser, working through exercises that build from warm-ups to real functions pulled from real shipped titles. Now run this forward. What does it actually mean to match a compiled binary when you don't have the source? It means you need the exact compiler the original developers used. For GameCube, that's MetroWorks Code Warrior, a compiler that shipped with Nintendo's SDK in the early 2000s. The community has preserved these tools, figured out the optimization flags, mapped the calling conventions, and built infrastructure to verify your output against the original ROM. The craft here is extraordinary. We are reverse engineering not just what the code does, but how a specific compiler from 2 decades ago chose to express it in PowerPC assembly. You're learning to think like a compiler thinks, and then to think like the engineer who wrote code that made that compiler produce those specific instructions. One of the comments asks whether you could contribute to ongoing decompilation projects through a similarly streamlined interface. That question reveals the real ambition here. These community decomp projects are massive collaborative efforts. Metroid Prime's decompilation has hundreds of contributors, and every function they match is a function that moves from opaque binary into readable, modifiable, portable, same. The entire game, reconstructed from first principles, available for anyone to study. This is preservation through understanding, not just keeping a ROM on a hard drive somewhere, but recovering the engineering knowledge embedded in the artifact. Every match function is a small act of archaeology, pulling human intent back out of machine code. And the whole ecosystem is open. The decomp projects are community-run. The tool chains are shared. The knowledge compounds because nobody gates it. 20 years after these games shipped, volunteers are reconstructing them instruction by instruction. And now they've built a teaching platform so more people can learn the craft. The compilers are preserved. The ROMs are preserved. The knowledge of how to bridge them is being taught in a browser. That's how culture survives. An anonymous GitHub account just mass-dropped undisclosed 0 days. Pause. And the implications are wild. Every few years, someone walks into the vulnerability disclosure world and flips the table. Right now, an anonymous account on GitHub called Bikini is dumping proof of concept exploits across dozens of projects. Everam keg levrezer tau, dogger gid rapid pitan mapcast. And the security community is doing that thing where half of them are furious and the other half are quietly checking their deployments. Let's talk about what's actually happening technically. The operator claims to have built a fuzzing harness, a structured framework for throwing malformed inputs at software until something breaks, and then automated the grunt work with AI, specifically GPT 5.5 Codex Spark for the fuzzing runs, with human oversight on the proof of concept code. The interesting claim is that model quality barely matters when your harness is good. A mediocre model with a well-designed fuzzing pipeline finds the same bugs as a frontier model. The intelligence is in the architecture, not the inference. Now here's the devil's advocate moment. The comments are skeptical, and some of that skepticism is earned. The Ghidra findings require overwriting binaries the user already trusts. That's not a 0 day, that's a precondition. The Docker issue is described by reviewers as a weird bug, not a vulnerability, and the term 0 day is doing a lot of heavy lifting here. A 0 day traditionally means an actively exploitable vulnerability with no patch available. Some of these are closer to crash bugs or theoretical attack chains that require conditions no real attacker would have. But dismiss the whole thing, and you miss what's actually significant. Even if half these findings are marginal, the other half aren't. The libisconsert use, after free, the FFmpeg parsing bugs, the CARES memory corruption. Those are real. And one person with a laptop and an AI automated fuzzing pipeline found them across 20+ projects in what appears to be weeks. This is the democratization moment for vulnerability research. The toolchain exists. The methodology is published. The harness matters more than the model. And critically, these findings are being dropped publicly. Not sold to brokers, not hoarded by intelligence agencies, not locked behind a corporate bug bounty NDA. published on GitHub with proof of concept code for maintainers to fix and everyone to learn from. The security establishment's discomfort is revealing. When findings come from credentialed researchers through proper channels, they're responsible disclosure. When an anonymous account dumps them publicly, it's reckless. But the bugs were there either way. The only question is whether they get fixed in public or exploited in private. One person, one harness, 20 projects, the tools are available, the methodology compounds, and the findings are open. So, you've got the tools to find the bugs. But what about the infrastructure you're trusting every time you hit enter? Let's talk DNS. Let's be honest about the counter-argument. Your ISP already sees your traffic metadata. Your browser leaks fingerprints. Your phone pings cell towers. Choosing a privacy-focused DNS resolver, the argument goes, is like installing a deadbolt on a screen door. Security theater for the technically anxious. It's a reasonable position, and it's wrong. Think of DNS like the nervous system of your internet connection. Every website, every API call, every background ping from every app on every device in your house fires a DNS query first. Your nervous system doesn't need to understand what your hand is doing to know that it moved. DNS is the same. A complete unencrypted log of your DNS queries is a near-perfect map of your digital life. And until you choose otherwise, that map belongs to your ISP by default. What makes this guide genuinely well-crafted is the filtering architecture. It doesn't rank resolvers on a single axis. It lets you compose your priorities: privacy and no logging, malware blocking, ad filtering, parental controls, unaltered DNS for purists. Then it cross-references against protocol support, DNS SAC validation, IPv6, operator jurisdiction, whether the operator is commercial or non-profit. The combinatorics matter because your threat model isn't my threat model. The engineering elegance here is quiet but real. DNS over HTTPS, DNS over TLS, DNS over QUIC, DNS crypt. 4 different encrypted transport protocols, each with different trade-offs in latency, compatibility, and censorship resistance. DOH hides your queries inside normal HTTPS traffic, making them nearly impossible to selectively block. DH gives you encrypted resolution without the head-of-line blocking problem that plagues TLS over TCP. These aren't academic distinctions. They determine whether your resolver actually works when someone is actively trying to prevent it from working. The comments surface a practical gap worth noting. Someone asks about public Wi-Fi captive portals that hijack DNS to force you through their terms of service page. Real problem, no clean solution. Yet, the plumbing fights back when you try to replace it. But the tools exist. Quad9, Molvad, NextDNS, your own unbound instance. Non-profit operators running global Anycast networks with no logging. This is infrastructure liberation, one query at a time. The nervous system of your connection should answer to you. DNS liberation is about choosing what your network trusts. Pause. Next up. Designing systems that respect what your brain can actually handle. I once spent 3 days debugging a distributed cache invalidation bug. Turned out I'd introduced it myself, 6 hours earlier, while fixing a different bug. I was holding the fix in my head, and the system's actual state had already slipped out of those 4 slots. I was building on a model of the code that no longer existed. Classic. This article by Shape of the System lays out the cognitive science, and it's devastating in its precision. George Miller's famous 7 items of working memory. Strip away sub-vocal rehearsal and chunking. And the real number is 4. 4 slots. A narrow attentional beam that misses gorillas beating their chest in plain view. A memory buffer that leaks most of its contents within 20 seconds. That's the instrument building your 100 million line operating system. The question nobody in this industry wants to sit with is simple. If the human mind can hold 4 things, and our systems require holding thousands of interacting concerns, then what exactly are we doing when we say we understand our own software? We don't. We never did. Every architecture astronaut drawing boxes on a whiteboard is performing a lossy compression of something that would take months to fully load into any single human's awareness. The uptime, as the author puts it, is the miracle. And here's the deadpan part. The industry's response to this fundamental constraint is the phrase, human error. Someone in a control room misses a warning that cognitive science tells us half of attentive people will look directly at and never see, and we file it under carelessness. Aviation figured this out decades ago. Medicine is getting there. Software is still writing postmortems that end with "be more careful next time," which is like telling someone to grow a bigger working memory. You can't. It's for One commenter nails it. System beats willpower. The answer isn't more discipline. It's better environments. Better defaults, guardrails that assume the gorilla will be missed. Because it will be, every time. The tools for this exist. Type systems, immutable infrastructure, progressive rollouts, chaos engineering. All of them are prosthetics for a 4-slot mind. The best engineering cultures aren't full of smarter people. They're full of people who've accepted exactly how small their minds are and built accordingly. So we've built the guardrails, pause. But how do we know they're actually working? That's where reflection comes in. 20 amino acids. That's how many options exist at every position in a protein sequence. And if you want to design a new protein from scratch, a binder that'll fold up and grab onto a target, you need to optimize probability distribution across those 20 options at every single position. The catch, your objective function is a protein folding model. Every evaluation costs real compute. Every gradient is expensive, and your probability vector has to live on the simplex. All values positive, summing to 1. The author's first instinct. And honestly, the instinct most of us trained in the deep learning era would have is to reparameterize. Slap a softmax on unconstrained logits. Optimize in logit space. Call it a day. It works. It's clean. It's what you reach for when you've internalized that gradient descent solves everything and constraints are just an inconvenience to be engineered away. But here's what the softmax hides from you. The geometry of logit space and the geometry of the probability simplex are fundamentally different. Gradients that look reasonable in one space can be wildly distorted in the other. The author discovers that projected gradient descent, literally just taking a gradient step and then projecting back onto the simplex, converges faster and produces better solutions for this problem. Even simpler, mirror descent with an entropic regularizer gives you multiplicative weight updates that naturally respect the simplex structure. Classical optimization, textbook stuff, dramatically better results. This is a bootstrap-ism story hiding inside a math blog post. The tools to do this right have existed for decades. Convex optimization, KKT conditions, mirror descent. All freely available knowledge. One commenter puts it perfectly. Introductory machine learning courses should cover basic optimization theory. The field built a generation of practitioners who reach for neural network tricks before checking whether a clean, principled solution already exists in the open literature. The knowledge is there. It's always been there. The question is whether we teach people to find it. This has been your daily tech feed for Hacker News for June 28th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet. 4.7. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something with what you already have. We'll see you back here tomorrow.